All right. Good evening to you all, and welcome back to class. Today is another wonderful day, and we want to continue with our studies. We want to tackle another amazing AWS service today in the storage category of AWS. Yesterday, we covered S3, and we saw how wonderful it is. We were introduced to Glacier, and we saw how amazing it is. Today, we are going to continue with the next lesson, and this is going to be another interesting service, and we have a whole lot to learn. This is day 10 of our training. This means we've covered several topics in this course. This is the AWS CCP certification examination. After this course, you are going to be a certified cloud practitioner, and everything we are studying here is preparing you towards that. And we have covered most of the essentials, and we have some left to cover. In the next few sessions, we will cover those ones so that we are all fully ready and fully prepared. And so let's keep learning, let's keep progressing, and let's keep covering all that the exam requires. And today, before I get into the lesson, I want to play a short clip. And after the clip, we will get right into the main lesson. If you are here, you can hear me, please put ready in the chats. If you are ready, let me know if I'm audible so that we can get right into it. Okay, so let me share my screen and we'll watch the clip.
Some of your data just needs to be stored, like for future reference or compliance. But long-term storage isn't simple when that data is this big. Doing it yourself? That means lots of expensive hardware, operational costs for running and maintaining it all, and more data. Let Amazon Glacier do it for you. Secure, durable, and low-cost, Amazon Glacier lets you store small or large amounts of data for a fraction of a penny per gigabyte per month and no costs up front. You pay only for what you use, meaning you don't have to predict the future or buy storage you don't end up needing. Amazon Glacier has 3 options for you to access your archives, varying from a few minutes to hours. Expedited allows you to retrieve data within 1 to 5 minutes. Standard means 3 to 5 hours to access your data, and bulk retrieves your archives within 5 to 12 hours. Amazon Glacier scales to store however much data you need to store, and offers options to store it in whatever AWS region meets your regulatory criteria. It ensures redundancy by making multiple copies on multiple devices in multiple facilities, and secures your data at rest with AES 256-bit encryption. With Amazon Glacier Vault Lock, you can retain and govern regulatory data and utilize compliant storage capabilities such as write once, read many at no extra cost. And you can even extend your data lake into archive storage using Amazon Glacier Select to filter and restore only the portions of an object you need, drastically reducing the cost of storage for your analytics solution and other applications. Amazon Glacier also works with other AWS storage services. S3 Lifecycle Management can automatically move cold data from Amazon S3 to Amazon Glacier based on policies you set. And to transfer data in and out of Glacier, you can use AWS data transfer services like the AWS Snow family. You can also use the AWS Storage Gateway in virtual tape library mode with most popular enterprise backup software to use Glacier just like you would use any tape library. Some of your data just needs to be stored. Amazon Glacier makes data archiving easy, affordable, and flexible for future use. Learn more, sign up, and begin using at aws.amazon.com/glacier.
All right, so yesterday we talked about S3 and we were introduced to Glacier. And Glacier is a storage service which uses an object storage model and stores data that is infrequently accessed. So if you have data that you don't access frequently, you can use Glacier. Yesterday, we discovered Glacier as part of the storage classes of S3. So if you are using S3, you can choose a storage class called S3 Glacier, and you can make use of Glacier. We don't require a full lesson on Glacier. However, it is important that Glacier is also a service that you can apply to directly or apply for directly, and it is the same as accessing it as a storage class of S3. It works on the S3 infrastructure, replicates your data across the availability zones, and it is low cost. So for this particular examination, the information we've covered about Glacier is enough and is all we need. Next, we are going to move on to block storage, and we are going to discover interesting features about how block storage works and what block storage is. We've already built a foundation on block storage, but we will now zoom in to the AWS block storage service called Amazon EBS. So let me share my screen and we will cover EBS. EBS is an interesting service. It is one of the best services on AWS and provides high performance block level storage for virtual machines. So let me move straight there. And we have been introduced to the history of AWS when it was launched, the key services they launched in 2006, and today the multitude of services they have. And for this examination, we are required to cover some core services, and we've done a great job over the 10 lessons that we've had to cover very, very essential services. And today we want to continue. We are done with compute services, and on storage services today we are talking about EBS. We've covered S3 and Glacier, and now we want to look at EBS, and EBS is an interesting service. After that, we will cover EFS, and we'll move on to database services, and then we will just wrap up for the examination. If you missed any lesson, please go back and watch the videos and make sure you get yourself acquainted with everything we have covered so far. When it comes to storage services, these are some of the key storage services, and we'll be including EFS for file system storage. And it is another very, very important type of storage on AWS. Today, we are moving to one of my favorite storage services, and it is EBS, Amazon EBS. If you are with me in the class, please type Amazon EBS in the chat. Let me see who can give us EBS, Amazon EBS. All right, so Lloyd says EBS, and we have Adewumi saying EBS. A lot of people saying EBS. And if you understand what EBS is, I want you to type what EBS stands for. What does EBS stand for? Type it in the chat for me. Type it in the chat for me if you know what it is. I want to see who will get it right. Who will get it right? Okay. So far, EBS stands for Elastic Block Store. So please take notes of what it is. Elastic Block Store. Elastic Block Store. Same as storage, but it is called Elastic Block Store. So let's keep that in mind. And it says that Amazon EBS or Elastic Block Store is a scalable, meaning we can scale up or scale down. It is high-performance block storage service designed to be used with Amazon EC2 instances. This is very, very powerful. It says that it is scalable and it is high-performance block storage service designed to be used with EC2 instances. So the concept of block storage, we have already covered that. And data is broken into blocks and stored. And this is the main block storage service when it comes to AWS. So anytime the examination talks about block storage or block level storage, let your mind go to EBS because EBS is the main block storage. And we also learned that block storage provides high-speed read and write access. And so it is so great for high-performance environments. And when it comes to virtual machines and databases, EBS is just the best storage service for the cloud. And one important thing we need to understand about EBS right now is that EBS is designed to be used with Amazon EC2 instances. Designed for EC2 instances. Please type that for me. Designed for EC2 instances. We have already learned about EC2. We didn't talk much about EC2 storage. We talked about EC2 compute. We didn't talk more about EC2 storage. We talked about the instance types and the various pricing models and the various reservations that EC2 provides. But today we are going to talk about the storage created for EC2. So this EBS that we are learning about today, we are being informed that it is special storage designed to be used with EC2 instances. So EC2 needs storage. Of course, it is a computer, virtual machine, it needs storage, and the storage created for it is called EBS. All right, wait a minute. Does it mean the virtual machines, EC2, don't have their own storage without EBS? The fact is that EC2 has its own storage. But the type of storage that EC2 has cannot store data permanently. EC2 has a type of storage that we call ephemeral. And ephemeral storage is a type of storage that cannot retain data permanently. It is only used for temporal data storage. For example, when it comes to personal computers, we understand that there are two types of storage. Our PCs have the RAM, the random access memory, and the hard disk drive or the SSD drive. This is how our computers work. And we know that the random access memory is the first storage service for your computer. But we know that the random access memory is volatile, which means it cannot store data permanently. The random access memory loses data anytime the computer goes off. This is why when you are working on a document or working on any task and you don't save and your computer goes off, you lose it because it is saved when you are working on it in temporal storage, but when the computer goes off, you no longer get it. But when you save it yourself, it is stored on another storage device or another storage medium. This means that, for example, when you are working on a document and you have not saved it, the current state is stored in the RAM. But when you save it, it is moved from the RAM to the hard disk drive or the SSD drive. And now your data is kept permanently. I don't know about you, but I have lost data before because I didn't save. I don't know if it has happened to you before. Please let me know in the chat, yes or no, if you have lost something before because you didn't save it. All right, yes. So a lot of people are saying yes, it is possible that you lose something because you didn't save it. Yeah, this is because what you were working on was not stored permanently. This is exactly the concept with EC2 instances in the cloud. The storage that EC2 comes with is just like your RAM. It stores data temporarily. It stores data that is frequently accessed, just like the way your RAM works. But it cannot store data permanently. And so we need permanent storage, just like we attach a hard drive to our computers. So EBS is like that hard drive or that volume that is attached to EC2 instances for permanent storage. And we are going to discover the terminologies we use in the cloud when we talk about permanent and when we talk about temporal storage. When it comes to permanent, we use a term like persistent storage. And when it comes to temporal, we use a term like ephemeral storage. EC2 provides block level storage volumes that persist independently from EC2 instances. So EBS provides block level storage volumes. All right, so whenever you hear storage volumes, think of it like hard drives or SSDs. Because as a matter of fact, if you have a hard drive, you need to have a volume on it and then a file system on it before you can use it. Yesterday in our previous lessons, we covered the concept of file systems. We couldn't cover concept of volumes and partitions, but this is how it works. For your storage device to work, like your hard drive, you need to have a volume and then a file system before you can use it. This should be understandable because we have understood how file systems work on storage devices. Your pen drive works the same. It has a volume and a file system. So EBS that we are working on today or learning today is the storage volume for EC2 instances. We know that it uses block storage, so it is called block level storage. That persists independently. And we say persist independently. These are terms used to describe how it works. And we say persist, the term persist or persistent refers to how it stores data, and it means it stores data permanently or it retains data, it keeps data. So it persists independently from EC2 instances. This means it is a type of storage that works, first of all, for the EC2 instance, but also does not depend on the state of the EC2 instance. Please listen to this. This means if something happens to the EC2 instance, the data is still kept on the block storage. This is important because the storage that EC2 comes with, that is the ephemeral storage, we'll discover the name very soon, works with the EC2 or is dependent on the EC2 instance. If something happens to the EC2 instance, like if the instance stops or it is rebooted or it fails, the data on the ephemeral storage is lost. But the EBS storage is still kept. And so we say that it is persistent and it persists independently from the EC2 instance. It acts like a virtual hard drive attached to an EC2 instance, providing persistent storage that retains data even if the instance is stopped or terminated. Again, this is exactly the concept of volatile storage or volatile memory and non-volatile memory. When we say volatile memory and non-volatile, we are talking about your computer. Your computer has two types of storage. One is volatile and one is non-volatile. Who can tell me which one is the volatile when it comes to your personal computer? Which storage is volatile when it comes to your personal computer? Anybody? Is the RAM. Thank you. Thank you. So if you took our lessons on computer hardware, this should be very, very easy for you. Okay? The RAM is volatile. And the term volatile, or when we say volatility, we are just referring to its ability to hold data. And it means that when it loses power, it loses data. So anytime your computer refreshes or restarts, anytime your computer restarts or goes off, the data in your RAM is lost. But let me ask you about the hard drive. The hard drive, if you have data on the hard drive, and let's say your computer has been off for 2 years, and even the hard drive has been disconnected from the computer for 2 years, if you connect it again after 2 years, will you find your data still on the hard drive? Anybody? Will you still find your data on the hard drive? Yes, of course. All right, because the hard drive is a non-volatile storage medium. It is non-volatile. The RAM is volatile. The hard drive is non-volatile. So the hard drive persists independently from the computer. This means that data stored on the hard drive is stored no matter the state of the computer. As a matter of fact, we can remove the hard drive from one computer, send it to another computer because the data is stored on the hard drive permanently. This is exactly the same concept when it comes to EBS and EC2 instances. Maybe we'll use different terminologies like persistent and ephemeral storage, but it's the same concept of volatility. RAM is volatile, hard drive or SSD or your pen drive uses non-volatile storage. Now, Amazon EBS allows you to create, manage, and attach volumes to EC2 instances, offering flexibility and durability for handling data-intensive applications. Data-intensive applications. So very soon we'll look at the use cases of EBS, and we will see that EBS is used for high performance and data-intensive applications. Now, let's talk a little bit more about persistent storage. Persistent storage means that the data stored on an EBS volume is retained even if the associated EC2 instance is stopped, rebooted, or terminated. I've already explained this concept, but this text confirms it. Persistent storage means that the data stored on EBS volume, when we say EBS volume, and moving forward, we are going to be saying EBS volume most of the time because EBS volume refers to the EBS storage. created for the EC2 instance. Again, EBS is storage designed for EC2. All right, EBS is storage designed for EC2. So if we know the compute service called EC2, then its persistent storage is EBS. And the term persistent means that the data stored is retained. Data stored is retained. Even if the EC2 that it was connected to is stopped, rebooted, or terminated. I want to find out if this makes sense to somebody, or if somebody has understood this. Okay, so that is it. If you've been able to understand this, then this is exactly what this lesson expects from you. This is exactly what this lesson expects from you. If you have been able to understand what we've said so far, number one, EBS is block storage. Number two, EBS is designed for EC2. And number three, EBS is persistent. These 3 points, they are just 3 points that we've talked about. If you understand these 3 points, that's it. Persistent means it retains the data even if something happens to the EC2 it was created for. First of all, we know it was created for EC2, but it is independent from it for good, because if something happens to the EC2, it still keeps the data, and that is a good thing. And we are talking about this because there is another storage that comes with the EC2 instance. So we'll be looking at that very soon, and that is called ephemeral storage. Please put ephemeral storage in the chat for me. Ephemeral storage. And very soon you hear the actual name. Ephemeral storage is telling you something about it. It means it is temporal, but we'll hear the name very soon. All right. So unlike ephemeral storage, which is temporary and tied to the instance life cycle, this makes a lot of sense because the EC2 instance has its ephemeral storage. Very soon I'll tell you the real name. But ephemeral storage means that the data lost is temporal. And the ephemeral storage is temporary and it is tied to it. What do you mean by temporal? Is it after 1 year or after 1 day or after 1 minute? No. It means that it depends on the life cycle of the EC2 instance. If something happens to the EC2 instance, then it is gone, just like volatile memory. Volatile doesn't mean it's 1 minute, 1 second, 1 year. So long as the computer is not rebooted, it is there. So long as nothing happens to the computer, it is there. But if the computer goes off, then it's lost. If the computer is restarted, then it's lost. That's the same concept here. Ephemeral works that way. EBS ensures the data retains or remains intact until the EBS volume is explicitly deleted. All right, so we are talking about serious things here. We are saying that when it comes to the EBS, the only time the EBS loses its data is when it is intentionally or explicitly deleted. What is deleted? The volume that was attached. What is the volume? The volume is the EBS storage that was attached to the EC2. So right now, we are not talking about the storage at the EC2 level. We are talking about the storage at the from EBS. So the storage that we create from EBS and we attach to EC2, unless the data is or the volume is deleted. Okay, so when you create let me use the term instance here. When you create an EBS instance, then it is called an EBS volume. So when the volume you created, or let me use it in terms of S3, when you create an S3 bucket, whatever is stored in the bucket is lost when the bucket is deleted. That's what we are talking about here. So when the volume is deleted, then it's lost. Of course, if you have a hard drive, you can also delete it, right? If you delete data from your hard drive, it's gone. If your hard drive is destroyed, it's gone. If you format your hard drive, it's gone. Maybe you can recover it, maybe not. Maybe not. Recovery is not 100%, depending on several factors. But of course, as tech people, we know that if a hard drive is formatted, a pen drive is formatted, you can recover the data, okay? One day I bought a new pen drive. It was so shocking. It was sealed in its case, but I just connected it to a recovery software. And unbelievably, I was able to retrieve local Ghanaian music, a lot of them from it. And I was so shocked, like, how? So, tech people, we understand that even if a pen drive is formatted, completely formatted, you can still recover the data. The data is not lost, it's hidden somewhere far away. We can recover it, even if you delete it. If you delete something, it goes to recycle bin, right? If you delete from recycle bin, we say it's permanently gone, but it's not at all. If you understand data recovery, you can get it back. Okay. All right. But then it is possible that you won't get it back as well, depending on several factors, especially when you are working with SSDs. One day, I mistakenly formatted my SSD, not the hard drive, SSD, and I applied all the recovery I know. I got nothing. And it depends. So sometimes there are certain things that will prevent it from coming back. But we know that we can delete from hard drives, which is permanent. Okay, so we are saying here right now, in the context of cloud storage and that EBS, is that EBS is permanent until the volume is intentionally or explicitly deleted. This makes it reliable for applications that need long-term storage. We know that a lot of applications run on EC2 and they need storage, they need long-term storage. So EBS is right for them. Now let's delve into ephemeral storage and let's look at the name of EC2's instance storage. Now, ephemeral storage refers to temporary storage that is directly attached to an EC2 instance. So here we have learned that there are two types of storage for EC2. Just like your personal computer, there are two types. The first one is ephemeral storage, and it has a name that I've highlighted here. Who can put that in the chat for me? Who can put that in the chat for me? We know that when you set up an EC2 instance, the EC2 instance will come with its own storage. That storage is called instance store. Instance store. So please keep it in mind. We are learning a lot about cloud computing. We are learning a lot about AWS, and every day we come across new information. All right. So the ephemeral storage, or the storage that comes with the EC2 instance, is referred to as the instance store. So when you hear instance store or instance storage, you should think of instance store, not EBS storage. And when you hear EBS storage, you should think of secondary storage for EC2, just like your hard disk drive is secondary storage for your computer. Because your computer's primary storage is not hard drive. Hard drive is not the primary storage of your computer. Your primary storage is the RAM. And if we use primary for hard drive, then we are talking about primary permanent storage for it. Because sometimes we refer to the RAM as just memory and we don't use the word storage most of the time for RAM. We use the term memory for RAM, but it's also storage. We need to understand. So your CPU doesn't work with your hard drive first. Your CPU works with your RAM first because RAM is super fast. So it can meet the speed of the CPU to exchange data. So whenever your CPU is working and it needs to store anything, it works with the RAM. Okay, I don't want to get into hardware right now, but it works with your RAM. It works with your RAM. And the CPU has its registers. That is also storage, but that is for another time. All right. So what we are talking about here is that the ephemeral storage refers to the instant storage that is directly attached to the EC2 instance. It is called instant store. The data stored in ephemeral storage is lost when the instance is stopped, terminated, fails, or is rebooted. So this is very important. All right. This is called instant store. This is local temporal storage that is physically. So the EBS, is it physical? Because we can provision it anytime. So is it physical? No, the EBS, think of it as virtual. Okay, think of it as virtual. And I'm sure that when we started talking about it, we said it is virtually attached. If you go back in the slides, so your EBS is attached virtually. But here we are hearing that the instant store is physically attached to the EC2 instance provided by the host machine. So in terms of the host machine, the story that comes from the host machine, if you understand the concept of virtualization, you know that the virtual machine, although the whole machine is virtual, the whole instance is virtual, it is allocated storage, or storage is allocated to it from the host machine. All right, so data in the instance store is lost when the instance is stopped or terminated. We've already established this. An EC2 instance can have both its own instance store, of course we know that, which is ephemeral storage, and persistent storage using EBS. Wow. This means that two types of storage can be attached to an EC2 instance. Already, I've told you that this is correct because your computer can have two storage. Your computer already has two storage. Your computer doesn't work with one storage. It works with the random access memory, which is one, and then it works with the hard disk drive or SSD. But listen again, an EC2 instance can have both its own instance store, which is called ephemeral storage, and the name is instance store. And we know ephemeral is talking about the fact that it is temporal, and persistent storage. The idea of persistent storage here is talking about it being permanent. So my question to you is this: how does an EC2 instance, this virtual machine, get permanent storage or persistent storage? Let me use the technical term, persistent storage. How does it get persistent storage? Who can tell me in the chat? How does your EC2 instance, please think of compute right now. How does your EC2 instance get persistent storage? How does it get it? How does it get persistent storage? Who knows it? Who can tell us in the chat? Let me see the first person who understands it and can tell us in the chat. Persistent storage. We are talking about persistent storage. I've already said that over and over. Okay, Wesley got it. Valentine got it. Excellent. Excellent. If this makes sense to you, that it gets it from EBS, then that's it. This is all that this lesson is trying to tell you. So it gets it persistent storage, and the idea of persistent storage is permanent storage or long-term storage. Long-term storage, it gets it from EBS. Now listen, without EBS, EC2 instances cannot store data permanently or long-term. Okay, so this clarifies it. This is why we really need EBS, because EC2 cannot store data long-term or permanently, but can only store data temporarily using its ephemeral storage called instant store. So when a question comes about how EC2 instance can get persistent storage, we have to understand that it comes from EBS. And without EBS, EC2 instances cannot store persistently, permanently, or long term. Okay. I don't know if anybody is lost. Are we following? Are we following? Okay. All right. So Frank is really following. Thank you, Lauren. All right. Don't be lost. All right. So now let's talk about EBS versus instant store. What is EBS? EBS is the persistent storage, and instant store is the ephemeral storage. So this subtitle, I could have titled it persistent storage versus ephemeral storage. All right. So these are the two storage, the two that we give to EC2. All right. So let's talk about EBS first, which is persistent. Data is retained even when the EC2 instance is stopped, rebooted, or terminated. We know that already. It is suitable for data that needs to persist over time. Okay. Now we understand the keyword persist. It needs to persist over time, like databases, file systems, or application data. Okay. Databases or application data. So let's understand this as application data. So over here, let's not confuse this with file storage. Let's just see this as application data. We are talking about data for high performance applications, data for applications that requires or are data intensive, suitable for data that needs to persist over time, like databases and application data. For example, EBS volumes are persistent and keep data safe until explicitly deleted. That's good to know. Now let's look at the instant store or ephemeral storage. Data is lost even if the instance is stopped or terminated. Data is lost if, okay, let me take it again. Data is lost if the EC2 instance is stopped or terminated. Data is lost if the EC2 instance is stopped or terminated. This is ideal for temporal data that does not need to persist, like cache or scratch data. This is important. All right, so we know that cache is very important to make computers fast. Without cache, your computer will not be that fast. For example, when you visit a website, the first time you visit the site, it downloads all the resources, like the images, like the JavaScript, like the CSS, and every data attached to it. It downloads them. And so if the images are heavy, you realize that it takes time to load. These days, we have a lot of high-speed internet, so we don't experience that. But previously, it was very, very clear. So it takes time to load the first time. At the second time, if you load the same page, unless you are loading a different page. But if you load the same page, it loads faster. Why? Because it caches all the images and all the scripts and assets that are downloaded. So next time, it will not download it again. It will not go online to download it again. It will use the copy on your system. So your computer has a cache memory, and even your whole RAM works like a cache memory, so that when you are using your computer, data that needs to be accessed frequently, they are stored in the RAM. So it doesn't have to travel to the hard disk drive to load data, or it doesn't have to download from the internet to access the data. So it stores it in its cache. This is why sometimes we tell you to clear your cache. Okay, because if something new is loaded and you are not seeing it, you have to clear your cache to see it. So the instant store is ideal for cache data or scratch data. So it's the same kind of idea. So let's just say you are working on a Word document. That Word document you are working on is temporarily stored as scratch data or cache data. If you are doing some graphic design, it is stored in memory as scratch data. If you have not saved it, or if you have not saved changes, and when you save it, then it is now saved in the hard drive. So the ephemeral storage is useful for that kind of high-speed data that doesn't need to persist. Example, instant store volumes are ephemeral and are wiped when the instance is stopped or terminated. This is the same concept of volatility, just that we are talking about virtual machines and ephemeral storage in the cloud. All right. Now, let's talk about the use cases of EBS, when EBS is used or useful. So, EBS is usually used for database storage. So in the cloud, MySQL, PostgreSQL, their data are stored using block storage on EBS in AWS. So AWS uses EBS for databases to store the data in databases. So anytime you hear of block storage and a use case of block storage, database is what should come to your mind first. Because the way block storage works, it is perfect for storing database data. Then, number two, applications needing low latency performance. Wow. Low latency means high speed, fast access. So applications that need fast access works with EBS. So this tells you how EBS works in high performance environments. It is also best used as boot volumes for EC2 instances. Boot volume for EC2 instances. All right. Next, let's talk about the volume types. Please type EBS volume types in the chat. Apart from understanding what EBS is and how it works, we've always said that it's not enough for this exam to know what it is and what it's used for. It's not enough at all. So when it comes to EC2, you need to know instance types. When it comes to EBS, you are required to know the volume types, because the volume types determine the costs of the EBS you set up or provision. So let's talk about EBS volume types. These are the EBS volume types. We have general purpose SSD. It is a default volume type of EBS. And most of the time, you see it referred to as general purpose or GP2 and GP3. And these are SSD. If you know the difference between HDD or hard disk drive and SSD, who can tell me what SSD stands for? I think I asked you this question yesterday or 2 days ago. SSD, what does it stand for? SSD. What does it stand for? Solid state drive. Thank you, Frank. Thank you. Thank you. Well done. All right. So the EBS volume types, the default one is called GP or general purpose SSD, GP2 and GP3. And this is cost effective. Then number 2, we have what is called provisioned IOPS SSD. Wow. And we refer to it as IO2, IO1, IO2. Provisioned IOPS. This talks about input output per second or input output operations per second. And this means special high-speed SSDs. We call them provisioned IOPS SSDs. We are talking about the volume types. Provisioned IOPS SSD. And most of the time when you talk about EBS and you want to go into details a little, you are going to be seeing this term IOPS all the time, IOPS. So we have IO1 and IO2, referring to the provisioned IOPS SSD. And this is high performance for critical workload. So for critical workloads, you use the high-speed provisioned IOPS SSD. Wow. We know how SSD is really, really fast over HDD. Now, the third point here, or the third type here, is called throughput optimized HDD. So here we have HDD, and who can tell me what HDD stands for? Who can tell me what HDD stands for? All right. So HDD is hard disk drive. Okay. So we have throughput optimized HDD. So this is another great one, but this one uses HDD and it is called ST1. So sometimes you are going to be seeing simple terms like ST1, IO1, IO2. Okay. So here throughput stands for data transfer speed. So even though it is throughput optimized, it is HDD. And this is used for big data and for streaming. Then we also have cold HDD called SC1, and it is archive-like data, archive-like data, archive-like, archive-like data. All right. So these are just the volume types and the names of the volume types, okay? When I ask you to tell me your name, I don't know your name until you tell me what it is. And you see how for some people's names, we have to struggle to pronounce. All right. So right now, what we are telling you now are the names of the types of the volumes. So don't ask me to change it or make it simple, or these are the names, okay? So we have GP2, GP3, called general purpose SSD. We have IO1, IO2, called provision IOPS SSD. We have ST1, called throughput optimized HDD. And we have SC1, called cold HDD. So here at least we've seen two HDDs and two SSDs. These are the names of the volume types or the types of volumes when it comes to EBS. All right. We are going to talk about the key features of EBS, and we'll talk about one of the most important features of EBS that you are required to know for the examination. And after that, we'll play a short clip and we'll play a short clip. And after that, we may take a short break and continue. One of the key features of EBS is called snapshots. Please put snapshots in the chat for me. Snapshots, snapshot, 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 snapshot. Okay, snapshots. So we are talking about the features of EBS and really, really key features. So one key feature is called snapshot. All right, so have you ever taken a snapshot before? Probably on your phone or your laptop screen. Have you ever taken a snapshot before? Okay. So there is this concept of snapshots when it comes to EBS volumes. Okay. So just like you have been taking snapshots, it's like you capture the moment. Something appears on your phone and then you just capture the screen, or something appears on your laptop and you just capture the screen. Snapshots. This happens to EBS and it is really important, really important. And without it, the knowledge is incomplete when it comes to EBS. So the idea of snapshots is important. Let's see how it works. A snapshot in Amazon EBS is a point in time backup of an EBS volume and stored in S3, Amazon S3. All right, what does this mean? So there is something called point in time backup. What this means is that at a certain point in time, you can take a snapshot of your EBS manually, and you can also configure for it to be done automatically. What does that mean? This means that you capture the current state of your EBS volume, and automatically it is stored somewhere. Here we are being told that it goes to S3. And I think that is very, very good, because if your snapshot goes to S3, it is really, really good, because we understand the durability of S3 and the 11 nines from S3 and how secure and safe data is in S3. So even though we are in EBS, our data is backed up in S3 using the concept of snapshots. This is very important information. So we talk about how EBS is backed up. We call it point in time backup. Please put that in the chat for me. Point in time backup. Point in time backup. Point in time backup. Let me see who can type that. Point in time backup. Okay. So a snapshot is a point in time backup of an EBS volume, and it's stored in S3. It captures the current state of the volume at the moment. Of course, I can't say current and at the moment. So it captures the state of the volume at the moment it is taken, okay? The moment it is taken. So you can take it. You can just click on something like action, then snapshots. Then it will capture for you. And it is used for backup, recovery, and replication purposes. Snapshots are incremental. This is another concept of snapshot. They are incremental. What does it mean? Meaning, after the initial or the first full backup, next time when snapshots are taken, only changes of the volume since the last snapshots are saved, making them cost efficient. Because when you are taking snapshots, you also pay for it. So when we start talking about the pricing model of EBS, you learn that you pay for the volume type that we just learned, and you also pay for the snapshots. Snapshots are not free, because you are going to use other resources like S3. So the first time, the capacity may be large, and so the transfer rate and a whole lot of other resources that will be used to do the transfer will be high. But the next time, anytime you do an additional snapshot, it doesn't capture the entire volume, but only changes made since the last snapshot, making them cost efficient. This makes subsequent snapshot faster, of course, faster and more storage efficient. That makes a lot of sense. They can be used to restore data. So if something happens, you can restore from your snapshot, create new volumes, you can create new volumes, or replicate data across regions and accounts. Sorry. Replicate data across regions and accounts. Snapshots are stored in S3. We know that already, but are managed by AWS. What does that mean? This means it is abstracted away from you, so you don't directly interact with it in S3 when dealing with the snapshots. So all we are saying is that when you take a snapshot, it goes to S3, but you don't go to an S3 bucket to go and interact with it. You just know you have a snapshot and the name of your snapshot, and we are telling you where it is stored, but you get a small serverless compute over there. Even though we know where it is stored, you don't interact with it in S3 directly. It is just kept there for you. And it also enjoys the features of S3. AWS uses a process called change tracking to identify modified blocks. So anytime you make changes, instead of snapping the whole thing, it snaps the modified blocks or the changes made. And AWS uses a process called change tracking, which is like a version control system to identify changes or modify blocks. All right. So at this time, I want to play a short clip about EBS, and I'll play another clip about snapshots. So let's watch this, and after that, we'll have a short break and continue with the rest of the content and close soon. Let me share my screen. So if you are ready, let me see ready in the chat, and then we get right into it. So anybody who's ready?
Amazon Elastic Block Store, also known as EBS, provides persistent block storage for use with Amazon EC2 instances that can scale and adapt to meet your performance requirements. Tightly integrated with EC2 instances, Amazon EBS provides high-performance, low-latency block storage with 4 different volume types to meet the needs of any workload. SSD-backed volume types deliver low latency and the highest IOPS, while HDD-backed volume types deliver the highest throughput, with 2 options for each type, depending on your performance and budget needs. SSD-backed volumes are best for boot volumes or transactional workloads, like enterprise applications, relational databases, and NoSQL databases. HDD-backed volumes are best for applications producing streaming I/O, including big data applications, data warehousing applications, and log processing applications, or for staging application-level backups before snapshotting to Amazon S3. For any type, you'll have consistent performance and be able to connect different volume types to a single EC2 instance for applications whose components have different performance profiles. Because you can modify live volumes without affecting performance or availability, you can adapt easily when your needs change. And point-in-time snapshots enable efficient backup, recovery, archiving, and creating new EC2 instances, all stored in Amazon S3, which has 11 nines of durability. With encryption in flight and at rest, Amazon EBS adheres to the most stringent compliance standards and regulations. Plus, Amazon CloudWatch can provide alerts when you need to adjust capacity or volumes. Consider it for your next high-performance application deployment in the AWS cloud. Find out more at aws.amazon.com/EBS.
Amazon EBS snapshots provide a simple and secure solution for protecting your block storage data. Increasing regulatory and compliance demands are driving you to retain snapshots for longer periods of time, increasing the cost of your storage. What if there was a way to save on cost while keeping archive data protected for years? Introducing EBS Snapshots Archive, a lower cost storage for full point-in-time copies that require retention for months or years and do not need frequent or fast retrievals. The EBS Snapshots Archive lowers your snapshot storage costs when compared to long-term retention in the EBS Snapshot tier. Note that your archive snapshots need a 90-day minimum storage, and there is a charge for retrieval. Effortlessly archive snapshots with a single API call, eliminating the need for custom scripts and third-party tools. EBS Snapshots Archive are ideal for your monthly and yearly backups, as well as end-of-project snapshots which need to be kept for compliance. Get started now.
All right, so we've heard a lot about EBS. We've seen the volume types and how efficient they are. And we've also seen the feature of snapshots. This is wonderful, and this is important for the CCP certification exam. At this point, I want us to take a short break. And after the short break, we will cover the remaining content and be done with it. Thank you very much, and I'll see you after the break. All right, so welcome back from the short break. Let's continue with our studies. If you are ready, let me see ready in the chat. If you are ready, let me see ready, and let's continue. Let me share my slides again. We will continue. All right. So we are still talking about the key features of Amazon EBS, and we've talked about the feature of snapshots. It is also important to talk about elasticity and scalability. Elasticity and scalability. Now, volumes are scalable, they are elastic, they can be resized dynamically without downtime. So when we started and I was defining ABS, the first word was scalable. So this means that it can be scaled up, scaled down, resized, enlarged, reduced dynamically. And it's important to see that this is done without downtime. It's done dynamically. Adjust storage size or performance attribute as application needs change. So when the needs of your application requires more storage, EBS can adjust storage size or allow you to adjust storage size and even performance attributes when the needs of your applications change. Another feature is called high availability and durability. Now we know that we get a lot of durability and availability from the fact that snapshots go to S3. But apart from that, it says that the data in your EBS is replicated within the same availability zone to protect against failures. So your EBS data is also replicated within the availability zone to protect against failures. We also have what is called multi-attach. That's another powerful feature of EBS. This allows you to combine different volume types like IO1 and IO2 volumes together to multiple EC2 instances for read and write operations simultaneously. Let me take it again. IO1 and IO2 volumes can be attached to multiple EC2 instances. So here we are thinking of multiple EC2 instances. You can attach IO1 and IO2 volumes. So this particular volume type or types can be attached to multiple EC2 instances for read and write operations simultaneously. So this tells us that EBS volumes can also be connected to not just one EC2, but multiple EC2. So this is a powerful feature called multi-attach. Then we also have performance optimized. And this says that fine-tune performance using configurable IOPS. So we have GP3 and IO2, these volume types. You can fine-tune their performance using configurable IOPS. You can fine-tune their performance. Then use EBS optimized instances to ensure consistent performance. EBS optimized instances to ensure consistent performance. When we're learning about EC2, we learned that we have compute optimized. Okay, we learned that we have memory optimized and storage optimized instances. So here, when we say storage optimized, we are learning that we can use EBS optimized instances to ensure consistent performance. That is very good. And this is performance optimized. This means that there are some EC2 instances that are optimized for storage. And so they store with EBS, as we already know. And we can use these EBS instances for optimized and consistent performance storage. Another feature is encryption. Encryption. Please put encryption in the chat for me. Encryption, encryption, encryption. From the concept of cryptography. So in the cloud, we have encryption, a lot of encryption. and encryption is a popular term. Provides data at rest encryption using AWS Key Management Service, KMS. Provides data at rest encryption using AWS Key Management Service. Ensures secure data transfer between EC2 and EBS volumes. So when there's data transfer between the volumes and the instance, it is also secure and it is encrypted. Encrypted. Just like yesterday, we talked about server-side and client-side encryption. Here too, from volume side and instance side encryption to ensure safe transfer and no man-in-the-middle attack. There are two subtopics to talk about, and we are done with EBS. First is billing and pricing model. Billing and pricing model. At this point, we understand how pricing and billing is important to AWS, and the exam, a large percentage of the exam objective covers billing and pricing. So billing and pricing is really important for the AWS CCP certification exam. Now, EBS pricing follows a pay-as-you-go model, okay? But it is determined by factors such as the volume types you select. So we talked about volume types. Also, the storage size or the volume size. Okay, so the volume type, who can give me one volume type of EBS? If you can give me just one volume type, then it means you are really learning and you are following this lesson really well. I want to get one person who is really paying attention and probably taking notes. Okay, sometimes you need to take notes. Okay, so the fact that we have the videos doesn't mean you shouldn't take notes. You need to take notes. All right. So code HDD is one, but I'm looking for those small terms like ST1 and those kind of things. So we have GP2. That's great. Thank you, well done. Yes. All right. All right. General purpose SSD, GP2. All right. So the pricing is determined by factors such as the volume type. And then after choosing the volume, of course, the volume needs size, storage size. So the storage size and the provisioned IOPS, input output operations per second. This talks about the speed and the snapshots. So snapshots also cost. Customers can choose the right configuration for cost efficiency while meeting workload requirements. So you can choose the right configuration that gives you cost efficiency and at the same time meeting your workload requirements. Let's talk about the volume type. The type of volume you choose impacts the pricing, most definitely. Amazon EBS offers various volume types for different use cases. One, general purpose SSD, GP3 or GP2. This is ideal for a wide range of workloads. Okay, we know that. Provisioned IOPS SSD, IO2 or IO1, designed for latency sensitive applications. We've already talked about that. For low latency, high speed applications. Then we have throughput optimized HDD, ST1, suited for large sequential data workloads, for big data and for streaming. Then code HDD or ST1, the volume type, best for infrequent access and code. Anytime you hear code in AWS, you should think of Glacier, okay? And you should think of archive, and you should think of infrequent access. Yesterday, we talked about standard IA for S3, and it refers to infrequent access storage class. So when you hear cold HDD, it is best for infrequent access and cold data storage or archiving. All right, so we've talked about volume type. Let's see how costs or volume size or storage size. So here I can say storage size, okay? Storage size, the same as volume size. EBS charges are directly proportional to the size of storage you provision, measured in GB, gigabytes. You pay for the total provision size, even if you don't fully utilize it, okay? So, newsflash, if you provision 100 gigabytes, then you are paying for it. So long as you have provisioned it, you are going to pay for it, even if you don't use it or you don't fully use it. If you provision 100 gigabytes general purpose SSD GP3 volume, let's say at 0.088 cents per gigabyte, so they charge per gigabyte. So depending on the volume type and then the price, okay? So here we are giving an example like GP3, which will go for 0.08 per gigabyte. So the exam may not be interested in the exact amount, but the billing model, okay? So we are telling you that the size you pay per gigabyte per month. That is what you should know, per GB per month. The monthly charge is 100. Here we are giving an example. So if you provision 100, then you are paying 100 times 8 cents, which is $8 per month, regardless of whether the entire 100 GB is used. All right, so that's a billing. So you are billed for the volume type and the volume or the storage size you provision. So if you provision 100, then you are paying 100 times the unit price, which is 0.08, or based on the volume type, it also have its unit price. But if it's 100, you multiply it by the unit price and you know your total. And regardless of whether you use all or you use just a little. Then the provision IOPS. For certain volume types like provision IOPS SSD, IO1, IO2, you are also billed for the number of IOPS you provision. Okay. This means that the provision IOPS, you need to provision IOPS in addition to the volume size. So you choose your volume size and the IOPS you want to provision. This is crucial for workloads requiring consistent and high performance storage. Then for snapshots, we know that snapshots are also charged, and they are charged based on the amount of incremental storage used in Amazon S3. Only the changes made since the last snapshot are stored. Let's read it again. Only the changes made since the last snapshot are stored. Okay, we already learned about that. This is incremental model. Optimizing storage costs, okay? Restoring a snapshot to a new volume incurs additional charges based on the size of the restored volume. So snapshots costs. When you take your first snapshot, you pay for it. But subsequent snapshots, you only pay for changes. So you pay less. But snapshots cost. And when you are restoring a snapshot or a backup, you pay for that because it takes a lot of compute resources to get the migration and the restoring done. Our last point is to compare S3 and EBS. What is S3? S3 is what we studied yesterday. S3 is the object storage we learned about yesterday, and today we'll talk about EBS, which is what? EBS what type of storage is EBS? Who can tell me in the chat? Because everybody knows. It's block storage. Thank you, well done. You're always smart. All right. Now let's compare. Amazon EBS and Amazon S3 are two different storage solutions in AWS, okay? each tailored to specific use cases and workloads. Use EBS for high performance, low latency, EC2 tied workloads. Wow. Such as databases and applications. That is really good. So you see how EBS is powerful. Wow. If you don't take time, you are tempted to always consider that. But then it is EC2 tied storage, okay? So if you want to use storage with EC2, then it's EBS. While S3 is ideal for scalable long-term storage for large data sets, backups, and unstructured data. So you can always get a bucket anytime. Let's look at this table, and this is my last slide. Let's compare type of storage. S3 is object. EBS is block storage. We all know that. Use cases. S3 for scalable long-term storage for data, backups, and big data. Wow. EBS for high performance, low latency storage for EC2 instances, databases, and applications. Then access. S3, accessed over the internet or APIs, okay? So we use URLs and APIs to access S3. Then EBS is tied to EC2 instances and attached as volumes. So EBS is EC2 tied storage. Okay, that makes a lot of sense. Scalability. S3 is virtually unlimited storage capacity. So your bucket can just scale unlimited, unless you yourself, you want to create a new bucket. But if you don't create a new bucket, it is virtually unlimited. Wow. Then EBS is limited by the EC2 instance storage and size of volume. So we know that you need to provision volume type and volume size. So data storage is based on the volume size you provisioned. That makes a lot of sense. Durability. For S3, we have our 11.9% durability across multiple AZs. EBS data persists within availability zone, but tied to EC2 instance lifespan. Data persists within availability zone. Okay, we already talked about that. But tied to EC2 instance lifespan. All right, so what you should take from this part is that we are talking about durability, and we already know that it stores independently or persists independently from the EC2 instance. We already know that EBS is not affected by the EC2 instance. But of course, it's created for EC2. So you need EC2 for it, but you just have to understand that it doesn't depend on the EC2. The data is always there until you explicitly delete it. We've already talked about that, okay? Cost. S3 pay as you go based on storage size and requests, okay? EBS, pay as you go also based on volume size. We talked about that. And performance requirements such as the provision IOPS. So the IOPS provision, that is it. S3 for data retrieval, suitable for infrequent access and archival data. S3. EBS, suitable for fast, frequent access, low latency data. Wow. Then performance, S3, optimized for high scalability, not performance. So it is rather optimized for scalability and not for performance. But EBS is optimized for performance, low latency, high performance access. Snapshots. S3 supported for backup and archiving. EBS supported for volume backup and disaster recovery. Same thing. S3, the region, data is stored in multiple regions. Okay, so yesterday we said that your data is stored within the region in multiple AZs. But the data can be stored also across regions. It's possible you can do that. But by default, the data is within a region and replicated in multiple AZs from yesterday's lesson. For EBS, data is stored within a single AZ. Of course, it needs to connect to an instance, so it's within a single AZ. So these are the differences between S3 and EBS. And this brings us to the end of today's lesson. Have you learned something today? If you're watching this video and you've learned something, please put it in the chat or the comment section. Let's know if you have learned something today. All right, so a lot of people say they have learned something today. It is possible we may have a class tomorrow, but you receive an email. And if our classes cross over to next week, since we have some very, very essential topics to cover, then we are going to have combined sessions in the afternoon. So please take notes in the afternoon, starting from Monday in the afternoon. Please take notes. Our lessons continue till next week, which is highly possible. Then we will continue because the time allocated for the AWS lessons is actually up. However, we have some very, very essential topics to cover. So we'll meet tomorrow on Monday in the afternoons. If we have a class tomorrow, you will be informed and we will have a class. I want you to enjoy the rest of the evening. Sleep well, rest well, wake up well, refreshed and strong, and have a beautiful day tomorrow. See you tomorrow. Expect an email and the details will be communicated. Thank you very much for joining the class. Have a wonderful evening and we'll meet again tomorrow. All the best. Bye-bye.